By now you've read the slide, so you know if you're in the right place or the wrong place. I'm excited to be sharing with you some of the lessons learned and best practices that we have developed, that Qualcomm has developed and that we have taken at Splunk towards ways to enable our customers to get even farther with regards to IT monitoring, especially using ITSI. But before we do that, anything we say that might be considered to be forward-looking should not be taken as a reason to buy or sell Splunk stock. Don't buy anything from Splunk unless you are already convinced that the product does what you think it should do. La la la. Any questions, you can ask me afterwards. I'd like to begin by having a little round of introductions. We'll start with Ryan Sims.
I'm Ryan Sims. I'm a staff manager at Qualcomm. I have over 20 years of experience as an IT professional. My background is actually in network engineering, but in recent years I've been focused more on cloud, automation, and now AI ops and analytics. Ben?
Hi, my name is Ben Marcus, and I've been working in IT for over 20 years, focusing on managing global computing grids. I was the technical lead for the telemetry project that you'll hear about today, and been fortunate enough to use and have been at every Splunk comp using Splunk now over 10 years.
Wow. And my name is Michael Donnelly. I am a technical product specialist at at Splunk, using ITSI. And I am now going to hand this off after we announce our agenda. So first we're going to have Ryan talking about the Qualcomms that they set out to solve. What's the business problems that were solved by this approach? Ben will be talking about the best practices that they implemented in order to get there. And then I'll further refine that in terms of ways that might take some of the other things we've learned in addition to what we've learned at Qualcomm to help you on your journey. So.
All right. Thanks, Michael. Yeah, Ben and I are very excited to be here today to talk to you a little bit about Qualcomm's journey and how we were able to use Splunk to really improve the visibility and support of one of our most critical services at Qualcomm. For those not familiar with Qualcomm, Qualcomm's been a leader in mobile innovation for over 30 years, developing technology through all the generations of mobile and is continuing that trend with 5G. Qualcomm invents technology that's in many different familiar devices, smartphones, tablets, many other consumer electronic devices that have mobile technology in them. Qualcomm is also in a lot of other industries that have IoT use cases, for example, smart cities or smart homes, and also the automotive industry. So to give you a context of where our team sits inside of Qualcomm, we are part of a global IT infrastructure organization, and our team owns the Splunk platform. Qualcomm has been a Splunk customer for about 10 years, and we have a very large deployment. We have hundreds of data sources that come into the Splunk ecosystem every day. We have thousands of users that log into the platform every month to consume that data for various use cases. Our team also owns an AI ops practice, and we own all the different components of that ecosystem, including like event correlation and processing, many of the point monitoring tools for infrastructure. We also own the CMDB, which for those not familiar with the CMDB, it's essentially an inventory of all of our systems in our infrastructure and all the relationships between them. And then we also own a software development practice where we develop software automation and services that serve this ecosystem, and also many of our IT organization, many of the teams inside of IT. So our problem that we were trying to solve is we have a very critical service, which is a high-performance compute grid environment at Qualcomm. And our engineering teams, when they're developing technology, heavily rely on this service. It's really more of an environment. It includes many different services that are all interdependent with each other. And it's very large and complex. We have tens of thousands of systems that span globally across many different data centers and many different services. And when something goes wrong in this environment, it's very complex. It's very challenging to figure out what's going on. And so our charter was really to help improve the visibility and the troubleshooting around this environment for our teams. So in order to do that, we started a project that we called the Telemetry Project. And we had 4 key objectives in this project. The first objective was to really break down silos across teams. And I'm sure some of you, this will sound familiar to you, possibly in your environment, in your company. But traditionally, we had individual teams that own all these various services. And Ben's actually going to go into detail about specific services later on in the presentation that make up this environment and some other use cases. But each of these service teams, they were very talented, did a great job of supporting their services. But the data was siloed, the point monitoring tools were siloed, the analytics was siloed. So anytime we have an incident, teams had to kind of talk to each other in a siloed manner. So for example, let's say the LDAP team would see slowness in their service. They would maybe call the networking team and say, hey, networking team, things are slow. Is there something going on in the network? The networking team would troubleshoot, get back to them and say, you know what, things look pretty good over here in the network. Why don't you go talk to another team, like maybe the storage team or somebody else? Obviously, this is a very inefficient way to troubleshoot. So we really wanted to solve this problem by democratizing access to the data and putting everyone's KPIs and analytics and point monitoring tools, at least at a very high level, on a unified platform. We also wanted to create health scores around our infrastructure services, and rather than the traditional way of looking at individual system alerts or individual system components, we wanted to see a more holistic view and have a health score that at a very high level, all of our service teams could see and get context on very quickly of how things were doing in the environment, and then use that to drill down and know where to go next to fix a problem. And ultimately, we wanted to do all this to improve our investigation time and our resolution time. When we started this project, this had kind of been attempted before at Qualcomm a few different times to kind of unify data and monitoring and analytics in one platform, and it really wasn't that successful. And we knew this was a very challenging project. So we realized we really needed to take a different mindset. So one of the themes we took was, hey, this is going to be a marathon and not a sprint. You know, we need to figure out what we want to focus on first, realize it's going to take a while to kind of build a foundation. And one of the ways that we did that was embracing this idea of continuous improvement and really borrowing from more of a DevOps kind of approach to software development, and more sort of a CI/CD approach. If you're not familiar with CI/CD, it's continuous integration, continuous deployment and delivery. And really in this context, it just means we can implement something, implement a KPI or a data source or a dashboard and some alerting, and then we test it out and iterate on that and very quickly make changes in the environment so we can make incremental improvements over time by iterating through this process. One of the ways that we practiced this concept was to review incidents that we'd have. So we'd have an incident, and after that incident, you know, we would find out, hey, did we detect the root cause for this incident? And if the answer was no, we would look at that root cause and say, hey, what was the root cause for that incident? And we'd ask more questions around it. You know, for example, you know, was the data to detect this in Splunk? If the answer was no, then we would consider onboarding that as a new data source into Splunk. We would ask, like, were the ITSI KPIs that we had built, were they detecting these root causes? If the answer was no, then we would consider onboarding a new KPI. We'd also ask, you know, did the affected KPIs that we had built already, did it change the color properly? Or in other words, did the threshold that we have set on that KPI, was it working properly? And if it wasn't, then we would just make that change. So we took this very iterative process to make changes and modify and tune our alerting and our KPIs and our data sources as needed as we were moving through the project. So what were the outcomes and some of the things we accomplished here? Well, we really were able to answer questions which we couldn't answer before. We got a lot of new insights into data sources that we never had access to before. This was really cool to see. As we started to engage with all these individual service teams to get KPIs and data and analytics from their systems, they brought a lot of creative ideas and said, hey, you know, there's a data source over here that we should look at. And often it was something we had never heard of or thought of before, and it brought a really great insight into that environment. We also identified key KPIs, developed and correlated services for better monitoring. Basically, we took data and KPIs from many different services and we combined them into one pane of glass. And this is really where the power of Splunk is getting diverse data sources and analytics into a single panel, or sometimes maybe one click down, possibly a glass table, into a traditional Splunk core dashboard, and Ben's going to show you examples of this later. But this is a very powerful idea where you can get, in a complex environment like this high-performance compute grid, it's very easy to see and correlate multiple things together, which is in just a couple of minutes. We really improved the collaboration across our teams as well. This was something that was really neat to see. As we asked these service teams, hey, bring your data and your KPIs to this unified platform so everyone else can see them, the first reaction we got was they didn't really want to do it because they were concerned about maybe being blamed for the outage. And the traditional old culture we had was, hey, I don't want to share my stuff, right? Or they were afraid that it might be misinterpreted in some cases, like, hey, these other teams don't understand my data, so they might think there's an outage when there's really not an outage. Very quickly, this changed, and teams were very open, and they realized, oh, okay, I'm going to be able to see all these other services' data as well as mine. And many of the teams actually embraced it because they realized that they weren't getting as many calls from all these other teams. Hey, you know, is storage down? Is there a problem with the network? Is there a problem with LDAP? Things like that. So that was a really neat thing to see. So that's the overview. And
Am I on? Can I add just one last thing?
Yeah.
So tomorrow, Ben will be talking about breaking down the silos in IT, Sam Schilling for his presentation then. But this is really a key point, right? So when we have been rolling out ITSI, and I've been doing that since 2015 now, a lot of times there are customers who say, no, I don't want to bring that data in because then somebody else is going to look at it and they won't understand it enough to make it make sense to them. Well, if you set the KPIs and the colors right, you will. But just to reiterate what Ryan just said, I mean, the reason what's in it for them is that they won't get phone calls when there isn't a problem. And we see this at customer after customer after customer. It's in your best benefit as a DBA to make sure that those database KPIs are there for everybody else to see, so nobody's blaming the database when it's not the database, or the VMware, or LDAP, or whatever. It's probably the network.
Yeah. It's always the network. I'm a networking guy.
At this show it is.
Yeah, so this was really, the thresholding thing, people were really concerned about that in the beginning, and they got over it really fast, to be honest. So that's the overview. Now Ben's going to dive into the details, specific services, and give you some examples of actual incidences that we had and some KPIs and dashboards. Okay, Ben.
Thanks, Ryan. So when we started off the project, at the very beginning, one of the things we did is we spent some time analyzing where were all of our major outages, like what were all of our P1s or major incidents, and then what was the cause. So we tried to figure out really where were people having the most pain, where were the admins having the most problems diagnosing errors and outages and so forth. So spending that time was really, really valuable. And these are 4 things really anyone could do. So we did that analysis and we figured out where the major pain points that we needed to get visibility. And we figured out that it was the core sort of infrastructure that was causing the most outages for all the applications above it. So we couldn't just monitor the applications. We needed to really get more visibility around the infrastructure and those core services that support everything. We worked with then all of the infrastructure owners to kind of understand how they were triaging, what they were doing during incidents, and sort of their process used. I think that process was just as important because we learned about what data they had or didn't have, what sort of KPIs and indicators they maybe had or didn't have. So spending time analyzing the pain and then working with the various service owners at the beginning was really valuable. And as Ryan mentioned, we found that the business was most impacted by our computing grid. So that was the place we decided to start. Of course, it was our most complex service. And then we also worked to start evolving the strategy after the outages to determine, we sort of started making that closed loop CI/CD that Ryan mentioned. After every outage, we started shifting to determine, hey, what was really the root cause? Make sure we have a follow-up with those teams. So we started evolving kind of the strategy. And as well, at the beginning, we knew we needed more observability. For us, that meant a couple things. One is the logs. We needed to figure out what was going on in this grid. And that was really a matter of just getting all the logs from all the applications and services into Splunk. So lots of different type of data sources, bring all that data into Splunk so we can track all those events. The second main area for our observability is metrics. So metric, data point over time, things like bytes in, bytes out, packets in, packets out, memory use, swap free. Those are just typical like Linux metrics. But then of course there's metrics for other areas as well. So we brought in metrics so we could see trends and understand anomalies and deviations. So we brought the logs in, all the textual things, the errors, we brought metrics in from all of our services, all of our environments. And then of course the third component is ITSI, which is where you define the services that we care about and the KPIs around our infrastructure. So for us, really, those were the main ingredients for observability. Couple of things that we found really helpful were change requests. When we did the analysis of incidents, of our major incidents, a lot of times we'd find there'd be an outage after a planned change. So something may not have gone as expected, or it may have cascaded and affected another service. So we had all that data in ServiceNow, so we brought that data into Splunk. And we found that the change windows, or our RFC process for changes, that data was actually very valuable. The other thing that really helped us with observability was user tickets, right? If there's a problem in the environment, what happens? You suddenly get a spike in user tickets or complaints about problems. So again, we had all that data, we brought that data into Splunk, and then we were able to leverage both of those items to help us better understand what's going on in our environment. So we were able to use those data sources when we were building Splunk dashboards and the ITSI glass tables. And for us, we went kind of across all the main technologies that comprise our grid, and I'll talk about that in a little bit. And we really started building dashboards to help investigate the deep dive of what's going on, maybe what's going on under the hood causing an outage, as well as ITSI for the service view. So it was the combination of the dashboards and ITSI that kind of gave us really good visibility and understanding of the environment. The dashboards, the deep dive analysis when something is wrong, ITSI, if you're familiar with that, there's lots of talks here about ITSI, and you could find, it will show you the entity and maybe show you something is degraded, but then the core dashboards are useful for understanding maybe if something changed, so diving into the deep data. And again, that combination of dashboards and ITSI is really what helped us with understanding the environment and then speeding up the remediation process after outages. So it reduced that time to get service back to normal. So I'll paint a little picture of what high level of kind of what our global computing grid looks like. There's thousands of servers around the globe. They're all interconnected and they're all running engineering jobs 24/7. And to support this grid, the infrastructure side of it, we have hundreds of LDAP servers, got hundreds of filers. We're very dependent upon NFS and storage. Of course, we got the network, which is connecting all these servers around the globe. And the users themselves, they access the environment. We have VMware, so they all have virtual desktops. All the jobs, of course, require licenses. A lot of the tools are licensed tools. So we have hundreds of licensed servers. And then the servers themselves are in multiple data centers around the globe. So things like power, cooling, temperature, the data centers have to be operating for the grid to operate. With ITSI, what we have here is we wanted to be able to understand when there was an outage or a degradation in service, what was the impact? And we're able to do that very quickly. And we broke it down by two methods. So here we have sort of the tree view by site. So we're able to determine, hey, if storage is slow, is it one particular site or all sites? In addition, we're able to break it down by the technologies that support the grid. So LDAP, licensing, our remote display, DNS, the networking, so we could determine if it's a specific technology that affects the grid. Is it one site, all sites? Is it one particular technology? If so, which sites? So we could slice it both ways. So this is a sample of our tree view. And basically, even if you don't know anything about ITSI, the idea is if it turns red or yellow, you'll see the impact. So that was super helpful for us. In terms of data, we found that synthetic testing was a really good KPI and data source. So for all of the infrastructure that comprised our grid, LDAP, DNS, NTP, if you're not familiar with NTP, that's time services. Time has to be synced. If time isn't synced, that generally cascades to failures across the infrastructure, and our storage. So we developed synthetic testing, or canaries. So the idea is this gives us an availability test, a performance test, and a sort of a data tone. LDAP, what's the point of LDAP? To serve LDAP queries. So how do we know if LDAP is working? We have a test, it runs every 5 minutes, queries every LDAP server. That tells us if the LDAP server is up and responding, and if so, how long does it take to respond? Is it performing well or not? We also then look at the results and count the results and ensure we get a correct value. So is the data coming back? Yes, it is. Is it performing? Yes, we're getting that result quickly. Is the data correct? That's our data tone. So those three things we built across all of our core services. LDAP, same thing for DNS. So DNS, all the servers, all the appliances, everything relies on DNS, core infrastructure component. So we wanted to know, are the DNS servers up and responding? Are they performing well? And are we getting the correct data back? So we have a system in place that does DNS checks. NTP, time, we needed time synced. We did a similar thing there. Ensure all of our time servers are up, responding, performing well, and we get the correct data back. Storage, similar type of thing for storage. Is storage working? Is NFS working? Create a file in NFS, check the timestamp, ensure the time is correct on that file, do some read-write operations. So with storage, every 5 minutes, we do storage transaction. Normally it may take 3 seconds, 3 seconds, 3 seconds. Suddenly it takes 95 seconds to do that same transaction. We know something is slow in the environment. So we developed these canaries and they became really good KPIs for ITSI, as well as a good data source to put on our Splunk dashboards.
So right around now you might be wondering, why are we talking so much about infrastructure instead of the applications that you care about, right? I've got a database and the database is important and it runs our HR system, or I've got an online web store. And the reason why is when we were working with Qualcomm and other customers, we found that about 45% of all P1s are caused by this stuff. And it doesn't matter if you're using a microservices architecture or if you are using a more traditional LAMP stack or whatever it is you've got for making your application as a whole work for your customers, whether they're internal or external. 45% of the time, it's a problem with something like DNS or LDAP or the things you take for granted. Because when those things break, they cause a P1, right? And you probably do have some good tools monitoring each of these things already in your environment. And if they're not all brought into one place, that slows down your ability to troubleshoot and triage. It causes the need to have a war room scenario. So bringing that information into one place is valuable to everyone who's trying to troubleshoot those P1s. This approach with the canary testing is a brilliant first way to get started. Test the things that are the most important way to measure, is it working, is it fast, and is it giving the right answers, and do that every single time for every part of your IT infrastructure. You only have to do it once. It's a small amount of data. Splunk charges license by the data, so there's no objection here, because this is something where you just do the effort once, small data, big return.
Sorry. Thanks, Michael. So for each of these core infrastructure components that comprise our grid, LDAP, DNS, storage, networking, and so forth, we built Splunk dashboards around the data sources. And we combined all these different data sources together. So this allowed us to quickly drill into each of these technologies. So for example, I'll describe to you a little bit, this is from our LDAP dashboard. So the top panels here were basically showing is our load balancer that sits in front of all of our LDAP servers. Is it getting timeouts talking to the back-end LDAP servers? The second graph is our canary data for LDAP. How well is LDAP performing? Is it slow or not? So we're able to take all the data around LDAP, put it together on one dashboard, and that gives us a good context for what's happening with this service. So you could see that when the load balancers were having timeouts talking to LDAP, our canaries were also showing slowness. So we know for sure that there was a problem with LDAP. In the bottom example here, we have some additional data sources. For example, all of our LDAP logs are in Splunk. So the LDAP servers themselves, we take the logs, for example, all the query logs, all the access logs, all the error logs from LDAP software, and it's in Splunk. And our LDAP software also logs information about how long it takes the server to process all the LDAP queries. So on the bottom graph is simply a sum of how long the software took to process all the queries. And even if you don't know anything about LDAP, what do you notice? Big spikes, right? Over 100 times, and this was an actual outage that we had. So all you have to do is know there is a problem. If it's spiking up that much, something changed. In addition, the graph right above it showed our canary, so the slowness. So we know the LDAP software is taking long to process queries. The canary is taking a long time to do its normal test query, their slowness. So we know something was going on with LDAP. So we built these type of dashboards for all the infrastructure. This same data we used for the ITSI KPIs as well. So we're able to leverage that data in multiple ways. So here's another dashboard we have. And by the way, thanks to Jenny from Splunk Professional Services who helped us with this one when she was on site. So this dashboard here, I'll describe some of the panels. So the top panel was some of our information from our filers, our storage filers, trending information about LDAP errors. So all of our filers rely on LDAP for getting their user and group information. So the filer data, we've instrumented that to log into Splunk as well. So we could track the number of errors the filers have when talking to the LDAP servers. The panels below is the same information. So during that same LDAP outage I showed you on the prior slide, here we could see what the impact was to the storage systems, which filers were affected when LDAP got slow. The panels below are from all of our Linux syslogs. So LDAP was slow, that affected the filers. When the filers got slow, then of course all the jobs running on all the Linux servers were logging NFS not responding. So we have that data in Splunk as well, and you could see that on the panel below. So immediately we know LDAP is slow, it's affecting the filers is affecting the grid, and all the jobs and all the hosts which were impacted. So being able to put all this together in one place in Splunk dashboards and see the information across the technologies was really helpful. And that allowed us to drill down into the root causes much faster and remediate issues much faster. And it gave us the visibility across the infrastructure. So now our storage team, when they're monitoring the storage, they could understand, oh, we know LDAP is slow or DNS was slow. So because the data from all the teams is mashed up together in the dashboards, it really enabled the visibility across all the different silos and groups and brought them together, working together off the same data set.
And Ben, just one point is, many of these dashboards, we start at a glass table in ITSI to get a very high level, and then you click into a service and it'll take you to one of these analytics dashboards to get a deeper dive for analysis.
So some best practices that we've kind of learned is after every outage, kind of try to adjust the approach, see what was there, did we catch it, or if not, okay, what do we maybe we need to add in to catch it in the future. We're never going to get everything 100%, but just keep iterating and evolving, and then we got pretty good coverage. Figure out like where the most pain was. So for us, it was the infrastructure, and we focused on that area and really got the benefits. So figure out where your pain is, That's the high value impact to the business. We worked very closely with all the technology teams. We really tried to make it a partnership with LDAP, DNS, networking, all the various groups that manage the infrastructure. We really tried to partner with them to help them understand their process, understand their flow, and really make it a benefit for them. So they don't get calls from other teams saying, hey, we think something's wrong. And we weren't just implementing KPIs for them. Like, they had a stake in it as well. And we found that partnership was really helpful. When it comes to the specific KPIs, don't be afraid to try something. You're not sure how it's going to work. ITSI is great because you can configure something and test it out. You could try it without maybe affecting the health score on a glass table. You could put it in and model it. But don't be afraid to try something. There were a couple times when we weren't sure what would happen, but we put a KPI in or we put a data source in, and then we watched it, and we watched during other outages if it took effect or not. In some cases, we left it. We found it was very handy. In other cases, we took it out. So just don't be afraid to try KPIs. When it came to the KPIs as well, is we tried to keep it simple as possible in some areas. So is the service working or not? Is it performing well or not? So sometimes the simpler KPIs we found for some areas of our grid were a little more helpful. Another thing is the canary tests. I talked about that a little bit. Those synthetic tests we found very helpful for our environment. And then training. So that was another very, very big thing, is really working with all the service owners and the various teams to train them on ITSI, how to drill down into it. For a lot of our users, they were sort of new. So we spent a lot of time training, documenting, writing blog posts, doing short screencast videos, and just hands-on sessions as well, walking through scenarios during outages, helping the various teams understand and the context. But that training was really critical for our success. So where are we going next? Well, we still have more data on board. We've got lots of requests from other users. We have additional sources. We're looking to bring that into Splunk. Build more dashboards. So very popular. We want to expand the dashboards with those new sources, and we have other teams as well now coming to us and asking us for more similar type of solutions. And ITSI. So we're going to expand the services out of our computing grid into other business applications as well. So we're expanding dashboards, we're expanding ITSI to other services as well. More training, can never do enough training. So training, we have more plans there. For our core Splunk platform, we're looking to upgrade Splunk, upgrade to the latest version, possibly leverage Smart Store as well. And we're looking at some new storage options to improve performance for. And then we're also going to be kicking off an enterprise security project as well. So I'm going to turn it over to Michael, who's going to talk a little bit more about ITSI and some best practices.
Thank you. So what I'm going to speak to isn't necessarily from Qualcomm, so I want to make that differentiation. So if I speak to something that they're not doing, I don't want to set any kind of misunderstanding there. So mostly this is a recap of what you've already heard, but sprinkling in a little bit of additional information from other customers, as well as, well, let me just say, I'm going to get through this really quickly so that we can get to any questions and answers you might have. So if you remember one thing from this session, it would be this, right? Improve your post-incident remediation process to loop back into Splunk in some way, or some other tool, if you're using something else for your IT, but I presume you're here for a reason. If you don't do that improvement, and it's crazy to me how many customers haven't done that, it's like, oh, we just had a P1, a major outage. Okay, well, we found the root cause. Let's hope that doesn't happen again. No, it's worth the time as the Splunk team to engage with whoever's doing those, the minks as they call them at Qualcomm, P1s or whatever you call them at your company, right? Make sure that you take the time to find the root cause and make sure that that is instrumented for next time. And by root cause, I'm not saying, like server 38 was down, we had to reboot it. Why was server 38 down? That's the root cause. Somebody tripped on the power plug. Okay, that's one thing. It's kind of hard to track and prepare for in advance. But if somebody was updating packages on it, well, the next time somebody's doing updates on packages, maybe you want to at least make a KPI go from green to yellow so you'll know that, hey, everything was fine. I saw an update, and all of a sudden, everything else went to hell. Maybe we roll that package update back out, right? That'll allow you to troubleshoot what is going on in your environment in a better way, a faster way. That's the goal of all this. Now, don't let that outage bite you again. Don't let it bite you the same way, anyway. In this last bit, we don't have time to sit on all those calls. We're busy. I'm sorry, it sounds kind of whiny. The reality is, if you invest that time, it'll be worth it. I promise you. Because if you don't do this, your environment will not continue to improve. If you do this, it will continue to improve. And that 4 hours you spend now is 4 less hours that you're going to spend on a Friday night on a war room. And isn't that time well spent? Okay. This is the recap, right? Did you have the right alert before the major incident? So if you're using ITSI, you might configure it to look for a sustained degradation in performance. It went into the yellow, but it stayed there for 100% of the last 15 minutes. Let that send you an alert before it hits critical. Think of how that's different from, Nagios in the 1990s. It hits critical, you get an alert. Well, that's great. Now I know it's already broken. What if you could get an alert before it gets broken, right? So the other piece to think about here is that ITSI is not the one-stop shopping, right? They made a great point of saying it is a tool in your toolbox. ITSI's job is to let you know it looks like there's a problem, whether it's using anomaly detection through the machine learning algorithms that it's got, or a metrics-based approach, or if you're bringing in all the alerts from all your other monitoring tools and letting Splunk analyze it there. Its job is to let you know that there's a problem to look at. Core Splunk and dashboards and all the other apps, as well as ITSI, are the full set of tools available for you after that incident has been detected. Again, if you get it back down to the root cause, I spoke a little bit to that. Was the data necessary to detect that already in Splunk? If it's not there, consider whether or not it's worth onboarding now. If that P1 just cost you $250,000, you don't have to worry about justification of spending, $5K of your Splunk license to onboard a new data set. Right? Next piece, were the ITSI KPIs there? Create them if they're not. The canary tests are the best place to start. It's easy to figure out what those are. And then the last piece is to configure automation actions and alerting as necessary. We have other ways to get alerted other than an email. And if you think about ITSI, now we can have Phantom automatically begin remediation of certain issues. You might trigger out to something like VictorOps for PagerDuty or whatever you use for escalation in your environment. Lob it over to that so that somebody gets notified more quickly. Or at the very least, open a ServiceNow ticket or whatever ticketing system you use. So rather than spend the rest of today talking about all the other best practices that we've come up with, I'll just point out that on answers.splunk.com, we have validated best practices for ITSI. This entire deck will be available for you to download. Everything we've talked about so far is in that deck, but there's about 8 or 9 additional best practices that you can read through on your own if you download the deck after the session. So at this point, let's stop and do Q&A. You can ask these wonderful gentlemen anything about the Qualcomm journey, or if you have other generic questions, I can handle those.
You guys got to threshold. You said you were tweaked it, which I totally understand, and I believe that you're doing kind of manual or static thresholding, you're setting a number manually and letting it kind of figure itself out. Did you try the adjustable analytic thresholding?
Yeah.
So
Yeah.
recap the question, please, before.
So the question was, were you doing the thresholding manually, or were you trying some of the adaptive thresholding in different machine learning tools that ITSI has? And we were doing both. For each KPI, we would evaluate the best way to do the threshold. In some cases, we would use the adaptive thresholding, which works really well for certain types of KPIs. In other cases, we had to do it manually, or we would do a custom profile of the adaptive thresholding.
Is there anything in your mind that stuck out that the adaptive this case, it never works. Is there anything like that?
I have an answer for that. Right. So what we know is that capacity-based KPIs, you don't need a machine learning algorithm to know that 100% CPU utilization is bad. It's always bad if you hit that and stay there. 0% disk is always bad. You don't need a machine learning algorithm for that. So capacity-based KPIs are the ones that are tracking, do I have enough capacity to get the job done? Those work really well with fixed thresholds. They really do. You could use machine learning to do a one-time set of what those thresholds might be for your environment, but just keep in mind that good and normal are not necessarily the same thing. Why would you want to auto-train green, yellow, red for your environment if you're in a crisis state, right? You would want to maybe bump those a little bit. The kinds of machine learning-based KPI thresholding tends to work really well for things that are user activity-based or automated activity-based. So if I want to track the number of expected logins on Monday morning at 9 a.m., of course it's going to have a spike and it's going to go down. Around lunch it's going to go down, it's going to go up after lunch and whatever, right? Those kinds of things where you're trying to see, are my business KPIs working? Are the usages of the system working the way that those should? Those tend to be the ones that are particularly well suited to using a machine learning approach to set the thresholds. Does that make sense? Okay. We have 3 minutes left. Wow. You first.
I'm sorry, could you just say the question a little?
The recap, right? Because I have to do it for the room anyway. Can you elaborate on the canary testing and how you got that data in? Did you use a universal forwarder? What kind of scripts did you use?
So the answer is yes. We got the data in different methods. One of our tests, we basically send the data to the Splunk HEC. So it's a custom script that runs at each site, and it just does JSON posts to the Splunk HEC, and we receive the data there. In another type of test we did with the canary, we had an external system that actually did the testing, and then to get that data into Splunk, we had to write a custom integration via the API. So we pulled out the data from the other tool via the API, and then brought that data into Splunk. And for a third type of canary we had, that runs directly on our hosts where we already have the Splunk Universal Forwarder running. So it's just monitoring log files and metrics and bringing that data in. So we use different methods depending on how we could get access to the data and where the data ran.
There were some down here, and then I see you next. Yes?
So other than Splunk, what tools are you using, and how much do you rely on just Splunk versus other tools in your ecosystem?
Other than Splunk, what other tools are you using, and how much do you rely on Splunk versus the other ones?
You want to take that one?
Splunk and ITSI, one of the interesting things is like, it's not really a monitoring tool in and of itself, right? You have to do the monitoring somewhere else, and then you bring the data in. So we have many different point monitoring tools, some legacy tools, some newer like cloud-based tools, a lot of the usual kind of suspects out there in terms of monitoring, and we just get them in through different sources. Like Ben mentioned, some of them are custom, we built, some of them are cloud-based or agent-based, and some of them are traditional like SNMP monitoring and things like that. So.
And I'll add that our users keep asking us to bring all the data in Splunk. So even if there are other point monitoring tools, we try to bring it into Splunk. It's the one place we have all the data, we could see everything, and then it feeds the KPIs and the dashboards. So Splunk is becoming much more popular, and even if there's other tools out there, we tend to integrate and bring all that data in wherever possible.
Right. So I'm afraid we are out of time on stage, so we'll have to take our mics off and such, but that doesn't mean we have to leave. So the three of us can move to the back of the room. Any additional questions you have, you can come back to us, ask, and we want to thank you for your presence here today. Thank you.